Today's video is going to be about kinetics and equilibrium in chemistry. Let's get started. Let's begin by going over the vocabulary. Kinetics is the study of a time-course behavior of a chemical reaction. Equilibrium thermodynamics predicts the concentrations of phases if a reaction reaches equilibrium. The first law of thermodynamics is that energy can neither be created nor destroyed, only changed from one form to another. The second law of thermodynamics is that for any spontaneous process, the process always proceeds in the direction of increasing disorder or entropy. Internal energy is the energy associated with the random disordered motion of molecules. Heat is the energy transfer from a high-temperature object to a low-temperature object. Work is the energy transferred when a force moves an object over a distance. Exothermic reactions are reactions that release heat energy. Endothermic reactions are reactions that use heat energy. Heat of formation is an enthalpy change when a compound is formed from its elements at a standard temperature and pressure. For the most stable form of an element, it is set equal to 0. Enthalpy is heat flow when processes occur at constant pressure. Activation energy is the energy that must be overcome in order for a chemical reaction to occur. Kinetics studies the rate of reactions, or how fast or slow the reaction is. It looks at how the molecules break apart and then form new molecules. A system in kinetics and equilibrium can either be closed, open, or isolated. A closed system does not exchange matter with its surrounding. An open system exchanges matter and energy with its surroundings. An isolated system does not exchange matter nor energy with its surroundings. Reactions can occur in a series of steps. The slowest step determines how the reaction will proceed. Some factors that affect a reaction rate are temperature, concentration, and surface area. The higher the temperature, the faster the reaction rate. The increased kinetic energy means that the molecules will move faster and they're going to collide more with each other. This creates more energy and more successful reactions. When the concentration increases, this also leads to a faster reaction rate because more molecules increases the frequency of collisions and successful reactions. When involving solids, a larger surface area exposes more molecules, so there will be more collisions and a faster reaction rate. Some other factors that affect reaction rate are the nature of reactants and catalysts. Nature of reactions refers to when ionic substances will react faster than covalent substances because in ionic substances, the presence of ions will allow them to collide at every angle. But in covalent substances, they're going to react more slowly because the bonds will need to be broken and then reformed. A catalyst speeds up reactions while not being consumed inside the reaction. Catalysts provide an alternate reaction pathway with a lower activation energy. Let's move on to talking about potential energy diagrams. So if the heat of reaction is positive, like it is in the endothermic reaction, indicated by the positive triangle H, then the reaction is going to be endothermic because this means that the products have more potential energy than the reactants, and this means that heat has been absorbed in the reaction. If the heat of reaction is negative, like it is on the left, then the reaction is exothermic because the products have less potential energy than the reactants, meaning that heat has been released as a product. The change in E, which is triangle E and is represented by the dotted line, represents the activated complex, which is the energy needed to start the reaction. It is at the highest point of the reaction because bonds are broken at this point and then they're reformed. Here's a different potential energy diagram so that different parts like the forward reaction and the reverse reaction are clearly labeled for you. So the activation energy of the forward reaction, which is on the left, EA, is the minimum amount of energy required for reactants to transform into products. Then the activation energy of the reverse reaction on the right, which is EA of the reverse reaction, is the smallest amount of energy needed to start the reaction in the reverse. The potential energy of reactants and products is the energy stored in the reactants and products. Chemical equilibrium refers to reactions that can occur in both directions. After some time, the forward and reverse reactions will occur at the same rate, so the rates will be equal. A system in a state of equilibrium is in a state of minimum energy. Concentrations are equal and the pressure and temperature are also constant. Collision theory. For a chemical reaction to occur, the reacting particles must collide with one another with sufficient kinetic energy at the right position. There has to be both in order for a sufficient exchange of energy to occur. Solution equilibrium. The distribution of molecules among the phases has reached a balance. Saturated solutions are in equilibrium. Le Chatelier's principle. If the system at equilibrium is distributed, the system will counteract the disturbance in order to return to equilibrium. So increasing the pressure will cause the reaction to favor the side with fewer gas molecules because it will reduce the total volume. Increasing the concentration of products will cause the reaction to favor the reactant side. Decreasing the concentration of products will cause the reaction to shift to the product side. Increasing temperature will make the reaction behave like an endothermic reaction. The system will shift towards the products in order to absorb the heat. Decreasing the temperature will cause the reaction to behave like an exothermic reaction. The system will shift toward the left to release heat. Moving on to practice problems, pause the video so that you can do each problem and then resume once you're ready to find out what the answers are. Here's the first problem. A reaction is most likely to occur when reaction particles collide with. The answer is going to be C, both proper energy and proper orientation, because in order for particles to collide, they need to have both enough energy and they need to be in a good position or proper orientation. The energy needed to start a chemical reaction is called the activation energy. If you remember the labels from the potential energy diagrams, the activation energy is the minimum amount of energy needed for the reaction. As the temperature increases, the rate of an exothermic reaction will also increase. This is because there's going to be more kinetic energy, which will lead to more energy for the collisions. This is the same thing as the last three problems, so just resume the video once you're ready to find out the answers. In which beaker will the reaction occur the fastest? The reaction will occur the fastest in beaker D because it has the highest concentration at the highest temperature. And the higher the concentration and the higher the temperature, both of these increase the reaction rate. Next, a catalyst works by decreasing the activation energy required for a reaction. This is just the simple definition of a catalyst, and it's very important to remember. Here's the next set of questions. The CuSO4 dissolves more rapidly when it is powdered because the increased surface area due to powdering permits A. Increased solvent contact. By becoming powdered, it increases the surface area, so it's exposing more of the solvent to collisions. Then, in a rechargeable battery system, the discharging reaction is exothermic and the charging reaction is endothermic. When the battery is discharging, it's using up what's power has been stored inside it, so it's releasing heat, and this is an example of an exothermic reaction. Then when it's charging, this is going to be endothermic because it's the opposite, and instead it's gaining heat and energy. Here's the next two questions. A system is said to be in a state of equilibrium when the rate at which products are formed is the same as the rate at which reactants are formed. A system being at equilibrium means that the rates have to be equal. It's not necessarily about the concentrations or the products or the reactants. It's focused on the rate. Then, what will the result of an increase in temperature be given the reaction in a closed system? When heat increases, the equilibrium will shift to the right because it's trying to balance the equation and absorb the heat. So the way you could think about this is the equilibrium is going to run away from the increase in heat, and then the side that it runs to is going to be amplified, so it's going to have an increase in concentration. Now try doing this short answer response. (43) State in terms of the concentration of SO3 what occurs when more O2 is added to the reaction at equilibrium. When more O2 is added, the concentration of SO3 increases. This is because when more O2 is added to the equilibrium, it's going to shift to the right, and this indicates that the concentration of SO3 will increase. Then for 44, it's very simple. Explain in terms of collision theory why increasing the pressure of the gases in the cylinder increases the rate of the forward reaction. Decreasing the pressure of the gases in the cylinder increases the number of collisions between O2 and SO3, increasing the rate of the forward reaction.